first in, first out buffer. So, our accelerometer is like generating data at a very high sampling rate, like 1,600 hertz. So if you have to read every single piece of data, once that piece of data is generated, your processor will be very, very busy. So the way, we do it is to first, temporarily store those data in a buffer that is sort of the FIFO buffer. Then we can just read, the buffer like every second so that, your processor will be much less busy. So that's the purpose of the FIFO buffer here. So we need to talk to our accelerometers. But when we say we talk to the accelerometer, who are we really talking to? So, we need to configure the accelerometer. We need to configure like, the range, what's the measurement range of the accelerometer? Then what's the data rate of the accelerometer? And what filters do you want to use on the accelerometer? We have to configure the sensor. We also need to read its status. We need to know when data is ready in the sensor, is there any error in the sensor, or is there an interrupt triggered on the sensor? So we need to read the sensor. And finally, we need to be able to retrieve data. So how can we do that? So when we say we talk to the accelerometer, who are we really talking to? So we are essentially talking to something called the registers. So simply speaking, registers are small, fast storage units that can be rapidly accessed. They are faster than like RAM and flash. So when we say we talk to the accelerometer, we are really just reading or writing these registers. So they are control registers. So for example, there's a register with the address of 0x41. This is the register where you configure your acceleration range. You just write some value into this register, then you change the range of measurement. There are status registers where you can know what's going on inside the accelerometer. Then there are data registers. So when you need to read acceleration data, you are really just reading these data registers. So they are very detailed specification in the data set, and you are going to do a little bit exercise in your lab 1. So again, we have our BLE SoC.